Given efficient synthesis of the following compound from the starting material given. So when we are looking at this, of course, we have an alkene here, and here this functional group is going to be an acetal, because I can see that I have two oxygens coming out of one carbon, and that tells me that I have an acetal. So for an acetal, I would need any kind of a carbonyl, not any kind, actually I should say aldehyde or a ketone carbonyl, and then I will need an alcohol, and in this case, since this is a cyclic acetal, I will need a diol, okay, for this one. So looking at this carbon right here, since this is the one that has both the oxygens coming out, it means that this fragment right here, this is coming from the carbonyl. It means the rest of the fragment is coming from the alcohol. All right, so that's how you kind of decipher this and split it apart. So once you know it's coming from the alcohol, it means that you need to convert the alkene to an alcohol, and more specifically a diol. Okay, so that you can then add a carbonyl to it in order to form the acetal. All right, so now at least we have a path to go to, and so now here we form a diol. So the best way to form a diol is using osmium tetroxide. It's a nice neat way. You want to make sure that you get your diol on the same side also, so you get a cis addition. You don't want an anti addition. It may not matter, I think, in the acetal formation, but still you want to get it on the same side because acetals are formed on the same side. So now what kind of an aldehyde or a ketone do we need here? So we need only something that has one carbon, because let me show you one more thing. Is that there are two hydrogens over here, and I know I make things a lot messy, but that's the way it is with me. So in any case, the aldehyde that you need is this one. So here is the H and the H, here is the carbon, and here is the carbonyl. Okay, so it's as simple as that. And then you may want to go ahead and write H3O plus there, because without the H3O plus, this reaction is not going to work. Okay, so that's that. That's how you do the first one. It's only 2 steps, but it's just trying to figure out how you will get there. Okay, let's look at the next one now. So in case of the next one, we have an alkene again, and now we are going to something like an alcohol and a nitrile on the same carbon. So we know we can get an alcohol and a nitrile used from a carbonyl. Okay, so and of course we are in the carbonyl chapter, but we can get that from an aldehyde or a ketone. So it means that I need to figure out how to go from an alkene to an aldehyde or a ketone, and the best way to do that is to form an alcohol first. So here you just do acid hydrolysis and you get an alcohol, and then you can go ahead and oxidize that using PCC. So once you add that, now you will have a ketone. Now once you have a ketone, all you need to do now is add HCN to this. So adding HCN or NaCN, both will work. NaCN is a better nucleophile, so the CN minus is the better nucleophile. So adding that will give you your nitrile and the alcohol and the carbon that you need. So simple synthesis.